Okay, as I told you before, this class will start late and finish now. I thought I could start it early, but now I see that we have a class right before this. We didn't have this last time, did we? No one was here. Anyways, so it's going to be shorter than what you see because I have to run to K building afterwards. So we have that, and I apologize, but that's how it is. So mostly our lectures are going to leak into the lab session. Okay, so we know that. Now, I'm going to start the session again by creating a new project, and then we're going to continue after that. All right, so creating a new project. C++ empty project, and hopefully this is going to be the last time I do this in class. Then you will select your repository, the one that you created in Workshop 0. I'm going to go to OOP244 Notes repository, and I'm going to go to section NBB and select the folder, and it's going to be called C January 12th. Okay? And always place the solution project in the same directory for now until we get to a point that we're going to have more complicated stuff to do, and then maybe you want to create a separate one for several projects in a same thing, but we don't have it now. So we create it and wait for it to create it. I'm going to add the source file. Sorry, wrong button. There we go. Add a new item, C++, and I'm going to C++, and I'm going to call it prg.cpp. Include IO stream using namespace std. Return 0 and cout OOP244 NBB January 12th. Insert a new line, Control F5 to run it and see if it works. And 3 years later it compiles, and you're going to have the executable running. Voila. Okay, are we good? Down to this point? Okay. So, quickly, let's bring what we've talked about last time. So, let me just open up the files we had last time. So we talked about modular programming, how compiler works. I'm going to put them one by one over here. Quickly review it. And also we said that compiler works as follows, which is essentially when you have several, just can I put this up? Usually you can hide these things. I guess cannot over here. Anyways, so we said that the compilers run like this. You have several modules in an application. Each module gets compiled separately on its own. 1.cpp separately by its own, 2.cpp, 3.cpp, 4.cpp. Compiler runs 4 times to call every individual ones, and it trusts you that all the things that you provided over there, all the things that you promised in your header files are available in other modules. Believing in that it will compile the binary language for it, the binary representation of C++ for it, and then after that, the linker is going to come, make sure that the promises you made are actually kept in other modules. If everything is cool, the executable is generated and ready for you to execute. And that's when you execute the executable and you see if the logic you have written is actually proper or not. If your logic is not, the process happens again. Each one of these things we call a module. And we said when you are creating a module, you have to go through a specific process, which is essentially each header file that you create will need to follow specific thing for compilation safeguards. We said every single header file of yours must have an if not defined, define, and end if in it to guarantee that the header file only gets compiled once. The name, the flag that is written for the compiler over here will get generated out of two things. One, the namespace in which you are going to write your code, whatever that is, you put it as capitalized at the beginning, underline, name of the header file, and you're done. And you always carry that for all your modules. And then you write the namespace you want to write stuff in. And for the CPP module of that, what you do, you simply include the header file and you add the namespace to it, and all your code will reside inside the namespace. And we said a module is used by a main, so essentially, oh, this is not the main for it. This is the one. Is it? No, it's not here. I thought that we have, did I copy the main over there? No, we don't have it, so let's do it here. So we said that when you are using that module, this is what's going to happen. You essentially include that module always after the the system header files. You include your own custom ones, never before. For now, take my word for it. Later on, I'll explain why. So in here, you are saying include. And now that we have this, let me actually bring them over here because now we are doing your review, and at the same time, I'm gonna copy it. And add it to here. Add existing item. So I'm going to add the student like that, and automatically it's going to put everything in its place. Now in here I'm going to say include student.h, and I'm going to say using namespace Seneca. Now I'm ready to use my so essentially this becomes what we call a unit test for our student module, where you can actually test your module and start working with it to do whatever is needed. We good down to this point? Okay? That's it. So this is how we created modules. We talked about namespaces and mentioned what namespaces are. We said namespaces are to prevent conflict in different abstractions of the same object. Okay? So you have a computer. From a student's point of view, a computer has specific specifications that you want to use and you want to keep. But if you want to use the computer as a store who wants to sell it, that's got to be a different thing. For you, it's important what's installed on it and what things it can do for you. For a store, it's what is it capable of, what is the price, and all this stuff. So two different abstractions. When two different abstractions are supposed to be implemented in the same system, that's where namespaces come to play. Each abstraction of the object gets implemented in its own namespace. In this case, we said if I have a student, again, we just talk about student. So in this one, we are saying if I have a student that with respect the needs of administration, and I have another student with respect the needs of education, then I need to have two different aspects of it, and because of that, you need to create two different namespaces for it. We said that namespaces can be used at the same time. If, let's say over here, say this ADM that I have over here, let's say I have student over here, and I have sorry, not class yet, struct, what do I call it? Subject. And I'm just going to actually put the ADM over here. So let's put this one over here. And, this is not subject. I'm going to bring the subject into the education part. Education needs to know what subject is. But ADM will have something like struct, say, loan. Or, what does administration need from you that the education doesn't? Yeah, let's put loan. Okay, so the amount of loan that you got, or if you're an international student, whatever. So this is what ADM has, and this is what education has. So if you have them both added, then you have to clarify which one is what. So I have STD, of course, for the system, but if I have over here using namespace edu, then this student becomes conflicted, the first one. We have to make sure that this one is called ADM. I'm going to save this in current thing. 01 namespaces. All right, so if you have two namespaces and you use them both, the classes that are carrying the same name, same custom types, we call them. If you use that, you have to qualify it by writing the name of the namespace and adding a scope resolution. But if you want to create a loan class or a subject class, you don't need to do it because one of them will be found in ADM and the other one will be found in EDU. Okay, so that's how namespaces work. Of course, what I have written over here is kind of a, demonstration of how all the namespaces are created in different modules, but it's not in the same file, but that's what you see. And the last thing that I wanted to remind you of is that when you have two namespaces with the same name, there is no conflict, they simply merge. Okay? Unlike classes, that when you have two classes with the same name, there will be conflict, then we need namespaces. We good down to this point? We're okay? Are we? All right. Okay, so that's that. So we have this. Yes, save it. So this is going to be, I'm going to call this one 02 student main.cpp. So to actually use the student, let me see. Oh yeah, good. So actually to use the student, you add the header file for the student and you use the namespace that student is implemented in it, and you go about doing your stuff. We go down to this point. Yes?
Why did we put using namespace setting?
Why did we? Because all the implementation that we do as students in Seneca, anything that you do will be created in namespace Seneca. And because of that, so essentially, what we are supposed to do is to have something like struct student here. Sorry. Struct student here. If I can type it, of course. Struct student here. And we have all the functionalities that we need for the student in our student.cpp. So I don't know, void register const student pointer, something like that. Okay, so student.cpp carries the methods, and I have no idea. Oh, register is a keyword. So reg is better. Okay, and this is const struct. Oh yeah, and remember in C++, to create a student, you don't need to write struct anymore. In C language, when you say struct whatever, then to create it, you had to write struct, the name of the type, the custom type, and then you create it. In C++, as soon as you create a class, which is a structure, it becomes a type. You don't need to worry about rewriting struct before it. You good? Okay? So if it was C language, I had to write const struct student pointer, yada, yada. But in here, I just write student. So any class you create, and please pay attention that I'm not calling a structure anymore. I'm calling it a class. Okay? Structures are classes in C++. They're not structures. What is the difference between a structure and a class? Just guess. What is the difference between a structure in C and a structure in C++? Guess. I didn't tell you this, so I just want you to see if you can guess. Anyone can guess? Do you remember what encapsulation was?
Yeah. It's like bundling data and behavior.
Putting data and behavior together. Pass it through.
Yeah.
So what is a behavior essentially? When we say behavior, we mean?
We put the function.
Functions, yes. So behaviors are functions. Putting the data and behavior, it means we put data and functions together, right? So the difference between a structure in C++ and structure in C is that in C++, you can actually put functions inside the structure. But in C, you can't. In C, structures are just records. In C++, they can carry action. Therefore, they are classes. Is that understood? Okay? How we're going to do it, we'll teach later. But because I taught you the 3 pillars of object orientation, one was encapsulation, the other one was encapsulation, the 3. Encapsulation,
abstraction, polymorphism, and
polymorphism. Abstraction is for everything. Thank you. Abstraction is for everything. It's not for C++. Abstraction you need to have to be able to program. You need to be able to narrow your vision to be able to focus on something. You need to pay attention to what is needed and ignore the rest. That is abstraction. It's not C++, it's for any language. But polymorphism, doing the same thing in different ways, that's the second pillar, or one of the 3 pillars of object orientation. So we had encapsulation, polymorphism, and what was the last one? Inheritance, thank you. And that means reusing your design. Unlike C language, where you rewrite functions to reuse your code, and then you pass, please, so I don't go around, okay? So, all right. So unlike C language that you had to, unlike C language that you recalled your functions to reuse your code, in C++, we inherit classes into new beings to reuse our old design. So you not only reuse your functions, but you use the entire design. And that's what we call inheritance. We're going to learn how it works in very close future. And obviously, because I have this reg thingy over here, I need to have this one in student too. So in student, you would have something like this. So you have the prototype in the header file. The class definition is in a header file, and the functions. As you see, I'm not putting it inside yet because I don't know yet. So I'm still doing it C style, but soon we're going to learn how everything works. Okay? So that's how modules work. Questions down to this point. It was a quick review on whatever we studied down to this point. Okay? All right. Now, so we know what modular programming is, and now we're going to talk about types, overloading, and all the good stuff that we have. So, first of all, types. When I'm talking about types, essentially, we need to focus on what major category of types exist out there. So when you are thinking about C language, okay, what are the 2 main category of types? Can you guess? Like, Like if you want to put any type that you know in C language in two different categories, what you're going to call those two categories? Can you guess?
Numbers and characters?
Thank you for the guess, but that's not correct. How about you, madam? You're not a madam, are you?
Pass.
I saw Go-
Pass.
Pass? Okay. What do you think?
Fundamental types?
No, thank you for Googling it, but no, that's not the one. So the types of any language gets divided into two things, integrals and real numbers. Integrals are integer numbers, essentially 1, 2, 3, 4, 5. Real numbers are 2.3, 5.6, and stuff like that, right? Now, can you give me some of the integral examples, like examples of integer variables, types? I'm going to write it over here as you do. So integer types, what do we have?
Like an integer.
Int, okay, pass it. The next?
Maybe character is also integer.
Thank you. We do not have anything called character in C language. There is no such thing as A or B or C. A is the integer 65. And you're asking the compiler to print the shape that is corresponding to the ASCII code 65. And then it puts a capital A. That's why if you add 1 to it, it's going to print B. So there is no character in C language. Remember that. We have no such thing. Characters are integers that happen to be big enough to hold the ASCII code of a number. So essentially between minus 128 to 127 if it is signed, or 0 to 255 if it's unsigned. We good? So character, int, what else? Do you know? Anybody knows anything? Anybody?
Boolean.
No, that's not C. I said C. We don't have Boolean in C. We don't have Boolean in C.
I mean, with a library.
Huh?
With a library.
No, we don't. In C language, there is no.
Return 0 or 1.
No, no. In C language, 0 is false. Anything but 0 is true. So 3.52 is true. We don't have anything called Boolean. Yes, ma'am. Loud, please. No, float is not integer. Float falls in the category of real ones. So character CH. So in here, I'm going to write the real ones, or floating point. So float is one of them, okay? And double is another floating point, thank you. And any integers, just int and char? We don't have any other integers? Huh? That's C++ too. It's not C. We are, no, C. C++. It's not C. Okay. What are you talking about is C, I think, C17 or C, something like that. It's not original C. There is no such a thing as, yeah. A short, thank you very much. A short. So actually, let me put it in a size. So we have character, that's the smallest one. Then we have short. And we have int, and what else do we have? Long, thank you. And then what else do we have? Long, thank you. Long. And then what else do we have? Long. No, I'm joking, it's just 2. Okay, so those are the things that we have. Character, short, int, long. Okay? So these are the sizes that we have. The sizes vary depending on the platform. Who has the microphone? Do you know what the platform is when we are talking about programming?
No.
No. So platform, anybody knows what a platform is?
Like ARM or like x64.
Yeah, it essentially means combination of things. One, the hardware. What do you have? Are you working on a Mac? Are you working on an ARM? Are you working on a Raspberry Pi? Are you working on an 8086 structure? What type of a thing you have? So that's, first is a hardware. Second, operating system. What is the operating system? I can run a Linux on that thing. So the platform is hardware that is usually completely masked with the operating system. So if you know the operating system, usually the hardware is not needed. So in our pay grade, the combination of operating system and the compiler you are compiling your code with together is your platform. Okay, so depending on platform, the size of these things change. I am in a 64 platform right now, so my long integers are 8 bytes. But if I go on 8086, then it becomes 4 bytes. So depending on the value, the values over here change. Floating point doubles, and do we have anything other than these? No, that's a different thing.
Since we can do long for something like int, is there something such as long?
Long double, yes, exactly, thank you. Long double. Okay, so this is, I think, 2 to power, I don't know, 7 or something. This goes 2 to power 100 something. This is go 2 to power 300 and something. So you can put something in here with 300 zeros in front of it, that big of a number. But always remember, that in floating point numbers, you never have precision. You can always say, this is float, sucks, Leary. I mean, like, lowest type of precision. Which means, if you write float A, B, and you set A to 2, and you set B to 2, and then you compare them, they may not be the same. One may be 1.9999, the other one be 2.00001. Okay? So you can never, ever in your entire life compare any type of floating point variable for equality. What you can do is to check their difference and see if the difference is smaller than the precision of your application. Like you do A minus B, if that value is less than 0.00001 and greater than minus 0.0001, then they are equal. Remember that, okay? Again, I'm going through all these things very quickly just to bring you up with yeah, so this is essentially what it is. Now, in C++, we have one addition, and that's bool, okay? Why? Because everybody was whining in C platform. You don't have anything to specify what is true or false, and what the heck you're doing. Like, people would get confused what it is. So they created what they call actually a bool. So bool falls into the category of integers. Okay, so in here you have bool, and you call it B. I'm going to call it B. So this could be either true or false. You can literally write true. Okay, if you print true, what's going to get printed? 1. If you print false, what's going to get printed? 0. But it's just made type safe now. By doing something like this, by writing a Boolean as a return value, you cannot return an integer. It's going to tell you, hey, what are you doing? You wanted to return a Boolean. Just, again, in C++, the type safety of C++ is to ask you to state your intentions, and the compiler checks to see if you are actually following that suit. That's the only thing. There is nothing extraordinary. You can still do crazy stuff, but you have to state your intention. It's like, I'm going to shoot myself in a foot. I'm telling you, boom, you can do it then. If you actually mention that you're going to shoot yourself in a foot, you're allowed in here. But in C language, you don't want to shoot yourself in a foot, but you accidentally do. So C++, type safety, so you have to mention that you want to shoot yourself in a foot, but in C you can't. That's type safety. It's not that you cannot, it's just that you have to state your intention before doing anything. We're going to learn how do we do this at the end of the semester and in OOP244. For now, we are just rookies. We are just going to do whatever we do. Okay? Yeah. Types. If you have any questions, stop me.
I saw in the class notes there are not type auto.
Oh yeah, we'll come to that. Okay. I'm going to go through it. Right? Okay. Another thing that we need to know is the prefix unsigned. okay, you can add it to the beginning of all integrals, not floating points, okay? To the beginning of all integrals to state that they are unsigned. Okay, how many fingers? Fantastic. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We good with that? Right? Okay. Now if I want these fingers of mine to indicate negative numbers, what do? I have 10 fingers. So either I have to set this one as 0 or this one as 0. So I'm going to say this is 0. If this is 0, I'm going to have -5, -3, -2, -4, -1. 0, 1, 2, 3, 4. So the biggest number is always one smaller than the negative number. That's what happens with unsigned. So if you add an unsigned to the beginning of a character, the minimum value will be -128, and the maximum value will be 127, always one less than the thing. You guys did binary stuff in any course? Like two's complement and things like that they didn't go through? So you know what, Boolean algebra, you know how to add two binary numbers? Do you know that? Okay, good. So if you know what I'm talking about. A negative number, there is no negative numbers in computer science. Negative numbers are essentially two's complements. So you want to make something negative, you get the two's complement, and still you add the two. It's exactly like algebra, where you say -2 + 4 means 4 - 2. Okay, it works that way. We good? Okay, so I'm not going to go into that because that's not the scope of our things. Okay. Now, we have something that I want you to completely ignore and never use it in OOP244. You have a question? Was that a question? Oh no, your hand was like that. I thought you have a question. Okay, so. And that is the keyword auto. Never use it, ever, ever, never. What is auto? If I say over here auto, I equals to 10. It only happens by initialization. You can only use auto for initialization. So essentially you're saying, I want the I to be of type of what I'm initializing it to. So essentially this becomes what?
10.
Integer. Becomes an integer. So if I do it like this, it's going to be what? An unsigned integer. If I do this, it's going to be what? An unsigned long integer. Okay? Please go find out what are the postfixes that you can add to literal values. That's your job. Go find out what to add to a literal value to make it specifically something. How can I make it an unsigned long, long, UL, and all the good stuff that you're supposed to do. Okay? But never use it. Why we have auto? It's for OOP 345 that you're going to learn actually how to work with STL and create templates. Templates are on-demand code that the compiler writes for you automatically. You're going to learn in future that we have vast library of written logic that can change its shape on demand. And because of that fact, you don't know really what the types are. That's why you do auto, or the types are so long that you want, like, for example, if I have something like this, that's the only thing that like, if I have unsigned, long pointer A. Okay? Now if I want to create a B of type A, I'm lazy. I'm just going to write over here, auto B set to A, not to type the whole thing. Okay? So, but again, you will see in future that, yeah, I'm not, again, forget auto, assume that it doesn't exist. Just know what it does. When we go to 3, 4, 5, you're going to learn it. Okay? So please don't use it because it's just for you. It removes readability for you. If you don't see line 5, you have no idea what is B. And that's not good. It creates hidden logic. I don't like it. Okay? For now, let's just stick to it. Okay? Okay? Questions? Suggestions? Objections? All right. I'm going to even remove that thing. Just remember what I told you. Let it be. I'm just going to write over here. That's the smallest thing that you ever had for a lecture for auto. So I'm going to save that because let's add a comment over here and say, I will be an unsigned int with exclamation mark at the end, okay? Oh, I have two twos. So what do I do? So it's, which one, the type what came later, right? So let's make this one 3. And now in here, I'm gonna go 0, 4, auto. Okay. Let's say I want to draw a line. We'll draw a line. Let's write a code for it. So if I want to draw a line, what do I do? Let's write a function. So I'm going to write over here void line. So if you want to draw a line in text mode, what are the things you need to give to line to draw a line for you? You need to know length, right? So the first thing is length. Of, okay. What else?
Start and stop coordinates.
Seriously? Now, so it's always from the beginning of the thing. Stop. Okay. Always, let's say always want to print from the beginning of it. So it's going to be length, okay? And the other one, let's say, what am I filling the line with? Dashes, dots, asterisk, what am I drawing the line with? So I'm going to write over here character fill, what I'm filling it with. We good? Okay. Now let's write the function. So it's going to be void line int length and character filled. See what I did over there? You see what I did over here? In prototype, always put a lengthy bulk name for your arguments, something that tells you exactly what the function is receiving. I hate, and I see my colleagues do that, I hate this, which is perfectly valid. Because you're introducing, using a prototype, your function, right? You are telling to the compiler, line is a function that receives an int and a character, and that's all compiler needs. But a person 3 years from now trying to debug your freaking code won't know what the heck is going on in here. Always in the prototype of your application, always put lengthy name for your arguments. If you want to use a small one over here, that's fine. But the prototype should be something, because this is going to go in the header file, right? And header file is always visible to everyone. So they can go to your header file and actually see what your line is supposed to do. We good? All right. So if I want to do this, then in here I'm going to say for integer I set to 0 and I less than L, and C out F and L plus plus. Oh, sorry, I plus plus. Oh, sorry. L plus plus, and I'm writing C out. We're going to learn that later, okay? C out F, okay? And then I'm going to go to new line. So C out and L. So that's going to draw a line for me. Now in my program over here, I can actually do this. Line.
I have a question.
Okay.
Usually the style guide shows different for loops. It restricts us from using a one-line for loop.
Yes, that's true. Absolutely.
So can we do it like this, or we should abide by the style guide?
abide by the style guide. Okay, so you're saying this is what we are asking in the style guide, correct?
Yeah, with the brackets and everything.
Yes. Okay, let me give you a quick example of why we did that. Okay, explanation. Okay, so when you want to learn how to drive, the guy sits over there with that ugly thing with the top of the in a car and with a sign over the student driver, and you're sitting over there and driving like that, right? So at that time, you're following all the rules and you're doing everything. But you become a professional driver, you go to a racetrack, then you can bend the rules and do whatever you want to do to be able to go as fast as possible. We are at this stage right now that I'm sitting beside that thing and try to learn how to drive. Doing this helps two things. First of all, not to wear glasses after 2 weeks, because when you write your format consistently the same way, muscle memory tells to your eye to jump where and where as you're going. So when you see a for loop, automatically your eye jumps over here to see what is being repeated. But if one is up, one is down, you don't notice. But every single time your eyes is trying to look and find what's going to happen next. Without you knowing, after an hour of debugging such a code, you feel headache. Because it's as if you try to walk and I ask you, you're not allowed to have equal size steps. Just think about it. Like that, please. I know it's going to look funny. Just go to Starbucks. From here to Starbucks, by the time you're there, it's as if you ran for 3 kilometers if you walk like this. But when you are having equal steps, it's muscle memory. Because of that, your eyes don't get tired. That's why we are having that. Okay? So for now, do that. And thank you for reminding. I was lazy. I'm going to do it properly now. Are we good? Okay. So line over here, and in here I'm going to say over here I want to have a line of 40 characters, and I want it to be filled with asterisks, let's say. We're good? So when I run this program, it's going to run, and we're going to see this. Yeah, it's going to run, and you're going to see the 40 line thing is going to come up. Come on. There we go. Oh, beautiful. I love it. What happened?
Instead of L++, you should have...
Yeah, okay. So, endless loop. So, this is one of the things that I write the code live because I want to make these stupid mistakes and then find out what happened. So, I added 1 to L instead of I. Okay? So, I'm going to go back and fix it. And you're going to see me making these mistakes all the time. Okay, so we have the thing and it's printing it and it's fine. Okay? But you don't want to always mention what is the fill. Like for example, let's say if I'm drawing the line, I want the thing to be drawn with dashes, usually. But sometimes I want to change it. So what do you do in C language? In C language, what we do is that we write another function, say void dash line, and we say int length, right? And we don't mention what is the fill because it's going to draw it with a dash. Right? And then we write the function over here. So void dash line, and int length. Now, because in this case we are drawing lines and they're all the same, I can literally call the other one. I can actually write over here line length and dash, right? We good? And if I want to run this thing, I can now say over here dash line. And I put over here 60. So dash line will actually run the schmiggly-dingy, and I'm going to have the proper thing coming up. So one is 40, and the other one is 60. Are we okay? Are we good? All right. That was C. In C++, we are saying that the compiler is wise enough, and because it's an object-oriented language, I should be able to do the same thing in different ways. Polymorphism, right? So you don't need to change the name of the function anymore. As long as the arguments are different, you can always use the same name. The compiler knows which one it is because of the arguments. So from eyes of the compiler, oh, excusez-moi, I forgot this. Compiler views this and it says, this is line with an integer. This is line with an integer and a character. And therefore, when this line is called, it knows it's supposed to call line 11, not 14. This is called overloading. It's the first thing you learn about polymorphism. Actually, second. The first one you learned in an IPC and you don't even know it. The first thing that falls under the category of polymorphism is casting. Right? You can write A is equal to 2 plus 2, then it becomes 4. Then you can say A is equal to 2 plus 2.5. Then it becomes 4.5. Did you change the plus? No, it simply casts one to the other. So it makes the 2 that is integer, casts it up to a float or double, and then adds the 2 and returns it, right? So those casting is still polymorphism. That is the first version of polymorphism that we already knew, and we didn't know it's polymorphic. So all the operations that you are using, anything, function calls, anything you have, when you had a function that accepted an integer and you passed it a double, and it automatically casted the double to an integer to be able to call the function, that was kind of polymorphism. It's not, it's really casting, but that's what it is, okay? In here it's the same, okay? So this is the second one. So first one is casting, polymorphism that we have, that we want to demonstrate, we can demonstrate. The second one is overloading. Overloading not available in C. So we can do it like this. And we can keep going. We can actually say, if you just say line by itself, if you just say line like that, then it means I want to write 79 characters to completely split the two things. Okay? So essentially I can do over here void, line, and I can write over here line 79 and a dash. Actually, I wouldn't write the dash. I would actually call the 79, so it actually calls the other one. Reusing the code, right? We good? Now I have 3 different functions, and I can call it in 3 different ways. And they are run just perfectly. This is called overloading. We good? Are we good? Yes.
I have a question. Why line without parameter? It brought a star, but why it know that it should be raw a star or raw a hyphen? Because if we have two pattern, one is a star and one is a hyphen.
I have the one that we have. I never called the star anywhere. I'm just calling it with a dash, right?
Yeah, yeah.
So when you write the line, it says 79. It calls this one and it calls this one. So dash will be printed. You can always add another one and say you can actually say something like this. You can write over here void line with a character. You can always do this and say like that. Now I can change only the character, but it's got to be 75, 71, 79. So you can actually write this something like this too. So we can say void line character fill, and then in here you will say line 79 and fill. So if they actually pass a character, then this will be called. As long as the arguments are different, you're good. You okay? You okay? Yes.
What does this program do?
It draws a line. It draws many lines, 4 lines in this case, 3 lines actually. Okay, I'm just demonstrating. If you wanted to write a program that draws a line, this is what you do. I don't know. Okay, so in here I can actually do line plus to start it and line plus to end it, and control F5 it. We good? Now, I'm going to try something in here. I'm going to comment this. No, let's not confuse you. So are we good down to this point? We're okay? All right. Okay, so now we know what overloading is. Overloading essentially means same name for the function, different argument list. Okay? Same function name, different argument list. And remember, return type is not part of the signature of the function. So another interview, I'm going to give you an interview question. Okay? So when you're going to someplace that want to hire you, they want to see how good you know C and C++. They're going to tell you what is the difference between a signature of a function in C and C++. The answer is C only takes the name as a signature, but C++ gets name with combination of the arguments. That's the signature of a function. That's how it identifies a function. We good? All right.
Another question.
Yes, you can have 5 million questions. Actually, where's my microphone? People are asking questions, and I'm not answering. Answering it properly. So since you
So it means that.
go ahead.
So it means that we can have, for example, the main function is the void line with the with the in length and sharp field, but we can have line in length or line sharp field or line nothing. We can have another like void.
Oh yeah, yeah.
all
So
for-
I see what you're saying.
Yeah.
So you're saying, can I let this be and only put that one? Is that what you're saying?
No, we can have
Only
one.
from the right you can ignore. So now we're going to come to the next thing, and it's got to be crystal clear. Give me 2 seconds, okay? Yeah. So do we understand this for now? Okay. Now, when the logic of the functions are identical like this, sometimes you don't need to overload. I'll explain to you why. So this one I'm going to write 0, 5, overload. So take a look at this. Not the character thing. Character is completely different because it's getting the character, not the length. But when you think about it, let me just align these things. These functions, this one, and this one. Actually, let me put it down. What is literally? What is the difference between 5 and 4? The difference between 5 and 4 is that if you call 5, fill is supposed to be a dash, right? That's the only logic. Correct? Do we agree with that?
Yeah.
So to write 5, I wish I could tell to the compiler, hey, if they didn't put the fill, please put dash instead for me so I don't have to write the code again. And the same thing for this one. For this line, what is the logic? There is no logic behind it. Essentially, line says, if they don't give me length and fill, length will be 79 and fill will be dash, right? So you can actually do that. You don't need to write the code. Compiler actually allows you to do that. So instead of, when the logics are identical, for this one, for that one you can't, because the order is not the same. So you can just remove these two. And you can say equals 79, which means if they don't put anything over there, put 79 for me. And if they don't put anything over here, put a dash for me. So essentially, when they are calling this, when they're calling that, it's not a match. It's got to bring the one that it is, okay? Let's be clear. For the second one, you're saying, I'm not giving any arguments. Compiler checks to the prototype of the function. Have they provided default values for the arguments? Yes. So I'm going to call the same function past the default arguments. So essentially, default arguments help you write different versions of the same function without writing the code, just changing the values. We good? Yes.
If it's the argument already defined, we can't change it. And for example, in the first one, it's line plus. So it's not going to change 79 length and plus sign, right?
It can because it can't at all because the types are not the same. It's not a match. line number 7 is not a match to line number 4 at all, because the first type is a character. The first type over here is an integer. Now, if you go C++ 99, it doesn't mean 2099, it means 1999. If you go over there, this would have been a problem, because at that time, C++ used to upcast the char to an integer. All characters were essentially integers. So these two would be a match. But now that it's more type safe, the two types are different. So the new versions of C++, you can actually do this, yes.
What about the third one? 40 and its side. That
Give me
one
line
is
number, please. Give me line number. Which line number? Give me line number.
Third. 40 and it,
Line number 3, you mean? This one?
no, I mean 9.
9, okay.
Yeah, sorry.
So you are saying 40 over here, right?
So is that would be fit in that?
Yes, so 40 goes for length, so 79 is dropped. And asterisk goes to fill, dash is dropped.
So even if they define, we can change them.
Yes, we can change them. We can change them to anything we want. So these are default arguments if the argument is not provided. If the argument is provided, the default values will be ignored. Okay? So if I ask you in a quiz, how many different ways I can call line number 4, the answer is 3. Not 4, 3 ways. Assuming if I don't have 3. If I don't have line 3 and I have line 4, this function can be called in 3 different ways. It can be called with both length and fill. It can be called only with length or with nothing. But you cannot let length to be defaulted and have this one as a value. So this call is a violation of C++ syntax. You can't say, I want to just ignore the first argument for it to be 79. You can't. This is a violation of C++ syntax. You can't. You can only have default values from the right side. We okay? We okay? That is one of the reasons that I always say to, whenever I'm teaching IPC 144, it's been a while actually, Evan, that you must concentrate on syntax and logic and understand, because when you go to 244, we're going to talk about C, but it's just giving you adding a little spice to C. So if when I'm doing this, you shouldn't think like, how the damn that for loop works, okay? So again, if you are weak in C language, it's a good idea to go review the things before we are going to more complex places. Your IPC 144 will kind of polish it, okay? And you know how, I told you how to use AI for it. If you have any problem with any parts of C language, just go to AI and ask it to tutor you the way I taught you. Okay, it's a very good thing to do. Again, we're gonna go to more complicated parts that at that time you don't need to ask me, what does this do? I'm like, you know what I mean? While I'm teaching what? You have to, yeah, you know what I mean. Anyways. So this is going to be 06, default argument values. Okay? And I cannot put a default value for this anymore. If I put a default value for this one, I'll be in trouble. Because then when it comes to line 8, it doesn't know which one to pick. Remember that. When you are actually creating your functions, you be the judge. If you're confused which one is going to be called, compiler is a bit confused too. Okay? Use your judgment. All right? All right. Again, one more time, I'm explaining that a structure, okay, when you create a class, we call that a compound type or a custom type. So whenever I say custom type, you have to think class, okay? A custom type is a type that is built out of fundamental types. Somebody said fundamental. Who was the fundamental? Good. You said fundamental today. So fundamental types are the types that are coming with the language. You cannot break it down into pieces, okay? That's why compound type are types that are built out of other types, fundamental. So I can, for example, I could have had something like this. So if I have over here struct subject, if I have something like this, I could have had over here subject, I don't know, size t, which is essentially unsigned integer. So whenever I write size t, that means unsigned integer, okay? So when I size t, student number, that's wrong because it is a member variable. You have to always start it with an M underline. Why? Because that's our standard notation policy. And any company that you get hired in, they're going to give you a 1,000-page document to tell you how we are coding here, and you have to follow it. So any variable created inside the compound type, it must start with an M underline. Why? Because in IntelliSense, it helps you. When you create an instance out of it, I'll show you. Anyways, so M student number, and in here I'm going to call subject M sub. So as you see, this compound type is built, and let me just add another thing just for the sake of argument. So character M name, and 60 characters for name, for example. Okay, so this compound type is built up of two fundamental types and another custom type, or a compound type. You good? All right? Again, because we are going early, I'm not going to give a break. We're going to end early. So please, when you come over here, bring your coffees and yes.
Two questions. What is size dash TS?
It means unsigned int. Size underline T. This means unsigned int M student number. So instead of writing that, so because whenever you want to show size of something, it's always positive. You don't have a shoes size of -3, right? It can't be like this. Because sizes are always positive, they created a new type. They called it size T, and size T is actually in the STD, using namespace STD, and it means it's an unsigned integer. If you're uncomfortable with it, don't use it. Just use unsigned. It doesn't matter.
What is unsigned?
It means it doesn't have negative. Remember 10 fingers, 0 to 9?
Unsigned means no negative,
Only positive. All right. So that's that. And if I have the subject at the bottom, okay, now this subject is not available anymore because it's at the bottom, right? If the subject is not supposed to be built, so let's say it's a pointer to a subject. If the subject is not supposed to be built, okay, then you can have a prototype for a class too. You can actually write over here struct subject. We'll see this soon. It's something that we're going to learn in future. So if you have a pointer to a compound type and that pointer is not available, okay, because the class is built underneath, you can always put a prototype before it. So as you did for functions, when the function is under main, you put the prototype at the top. You can put this one at the top. So prototype of a class is called forward declaration. It's just another name for it. So forward declaration is essentially prototype for a class. This is forward declaration. Should I write or write? What do I write? Yeah. Forward declaration that is prototype for a class, class or structure, okay? We're good? Okay, but again, if you do it like this, then you can't. Think about it. Because now you try to build the subject. If subject has 5 different things in it, that is not enough information for C to be able to create it. When you have a pointer, it's address. Like give you an envelope. On an envelope, it says 32 Young Street. Looking at that, you have no idea where are you going to. Is it a building? Is it one house? Is it an apartment? What is it? You have no idea. It's just an address. So addresses are okay. Okay? But when you write the whole thing over here, compiler tries to build the subject inside the student. And because it doesn't have enough information, it will fail. So remember, only forward declaration works for pointers. Only for pointers. So essentially, this becomes a definition, and this is this becomes a declaration. This is a declaration, and definition is essentially, we'll find out later on what it is. Not now. So whenever we say declaration, we mean prototypes. Whenever we say definition, it means what it does and how it's formed. We'll come to it soon. Okay. And there is a one definition rule. It means you cannot have two structures with the same name unless you have it in different namespaces. And that one definition rule is enforced with that safeguards that you put for the header file. So the safeguard in the header file enforces one definition rule, which means you can have only one definition for a compound type. And that's what it is. My name is Fardat, but it's a non-common name in Canada. So call me Freddie from now on, okay? So you can call me Freddie. That's if it's easier, okay? So if I do that, now do you have two teachers or one?
One.
But with two different names, right? So the very first name is my original name, Fardat. The second one is my alias. We have that in C++. In C++, you can give aliases to already existing things. And that brings up magic. We'll go through it in a second. Okay? Okay, I saved this already as overload, I think, right? Yeah, overload, I did that. And default target, everything, yeah, everything's done. So I can just remove it. So if I have over here, say, double D, and I'm going to set it to 123.4567, if I have something like this, I can always give this a new name. I can say double. Now you put reference, not asterisk. When you put an ampersand after a type, it becomes a reference, which means an alias. Now I'm going to call this one R, and you have to set it to an already existing, otherwise it's going to fail. You cannot have a reference like this, because you are saying R is an alias. It's incomplete. Alias for what? Right? So that doesn't work. You have to mention what is it referring to. That means now you have one double with two names. One is R, the other one is D. If I actually print R, and I set R to 345, 1, 2, 3, and then I go C out D. You will see that they are the same.
If we don't define R as a 345.132, will we be printing the same number?
Yeah, of course, the same number. They are. You literally have one double with two names. Do the math. Yes.
So does this mean like store R at the address of D?
No, no, no. This ampersand is not address.
So it's different.
Don't say. It's literally called reference. Okay? So I'm going to do because most of you, when I say pointer, everybody runs for the door. Okay? So I'm going to do my lecture that I do in IPC 1444 pointers I'm going to do it the next time you're coming here. So I'm going to go through, so that the lab that you're coming, we're going to have a pointer session. I'm going to explain to you exactly what pointers are. Okay? Funny thing is that I do the same thing with 345. Because when I go in 345, still they don't know what pointers are properly. So next year, if you're my 345 class, my apologies, you're going to get that again. Because I have to make sure everybody knows. So if the asterisk comes after the type, together they mean pointer. The asterisk doesn't belong to the other one. Lots of people write integer, then asterisk p. That's wrong. You have to write integer asterisk, space, p. That's correct. P is the name of the pointer. We're good? Down to this point. Okay. Now to show you actually that is true, I'm going to say cout. Now this is going to be a difficult part with our knowledge. Let's see if it's going to work. Cout, I'm going to say unsigned. Unsigned. Remember casting from IPC 144? So I'm going to say unsigned long, and I'm going to put over here address of D. And a space, I'm going to write over here again, unsigned long, and I'm going to put address of R. And I'm going to print them both. Okay? So when I run this beautiful program of mine, 3 years later, when it comes up, you will see this. The addresses are identical, which means I have one variable. When they're sitting at the same place, it's one thing, right? And that's essentially what it is. We good? We're okay? Now, I said it has beautiful side effects. Let me explain to you what they are. 07? Yes.
So I would like to confirm, because the pointer is an address of something, so the reference also the address of something as well.
You're asking questions that are too rich for our blood at the moment. So let's open a new category called aliases in C++. How it's created underneath, you have to go to university and get compiler design course. Then they tell you what references really are. You don't need to know that. From our point of view, references are aliases that can be a new name for another already existing thing. Always keep it, it's a new category. Okay, remember it that way. Okay, are we good? So, next thing. Okay? Now in here I have what is the output of the following program? That's your midterm. What is it going to be? Yeah, you said, yeah.
Oh, 20?
20. Why? Explain.
Because the void doesn't return.
Okay, so when you're programming, you have to put your microscope on your eyes when you're actually writing code. You have to know how a function is called in C language. How a function gets called? So the argument that you're writing over here is essentially a variable. That's how functions are called. But the difference is that these variables are always initialized. What they are initialized to? The arguments that you pass. So when the function when you are calling the function will be called as this: add 10 int val equals a. That's literally how it's being called. Now let's digest that. I am creating integer val a. So val is a copy of a, correct? So val is created in here, and then 10 is added to it, correct? What does it mean? It means that copy will be added by 10, that is 30. When it comes out, val dies. It comes back in here, a remains 20. We clear on that? Now, if I had this, integer pointer val ptr, then I could say target of val ptr plus equal 10. Oh, plus equal 10. And if I wanted to run that now, I can say add 10, address of a, and I'll go see out a. And how is this one called? It is called like this, add 10, integer val ptr, wow, integer pointer val ptr equals to address of a. That's how it's called. Let's analyze it. So val ptr will be the address of a, correct? So when it comes over here, you're saying go to target of val ptr. What did val ptr got created with? Address of a, right? So it adds the value of a. Therefore, a will be over here. $30. Are we good? That's IPC 144 with a touch of C++ because I didn't need to change the name of the function. One is pointer, one is regular integer, so it knows which one to call. I don't need to worry about it. But the one that I'm passing an address, the one that I'm passing an address with, will call the one that has a pointer. The one that is just an integer calls the integer one. Are we good with this? I'm going to call it add 10 IPC 144.cpp. Now I'm going to do over here, I'm just going to hit my keyboard once. So I'm going to put this one over here, actually twice. What happens now? Let's analyze it. I'm saying add 10a. It's going to say add 10. Val is a new name for a. So when it comes over here, it's adding 10 to val. What is val really? A is added by 10. Done. No more ampersand, schmampersand anymore. That's one of the beautiful side effects of creating references. And we have 30 and 40 now. Are we good? Okay. And after this, I'm going to show you something that's going to go, what? We're going to come to that point in a second, okay? 08. And this one is going to be the one that's going to add 10 OOP244 references.cpp, okay? Now I'm going to do something. Hold your breath. Let me just take this out first, the pointer thing. It was because we don't need it. And in here, I'm going to remove that. Hold on for it. Integer reference. I'm returning a reference, and in here I'm going to say return val. And in here I'm going to say what the heck that means. How can I have a function at left side of a damn thing? It's not going to work, right? But think about it for a second. Let's analyze. Add 10 is receiving a, and val becomes a new name for a, correct? It comes over here, adds 10 to a, then returns val. So the function itself becomes a new name for val. That is a new name for a. Therefore, add 10 itself is a new name for A. Therefore, you're going to have 35. Crazy, right? So if I run this, that's what you're going to get. Okay? So, hard to grasp. Please go home and think about it. And just to remember what I'm talking about, I'm going to write over here 10, and I'm going to write a crazy reference. No, I cannot put exclamation mark. It means something in operating system probably, right? So again, remember that. So I could actually let's remove that 10 thingy over there just to understand what's going on. If I do this, it makes it more simple. A function can return a reference of something that is out there. And if it does that, the function itself becomes a new name for what it's returning the name of. So now I am passing a reference of val in here and returning the same thing, which means add 10, which is wrong now. Reference of, let's call it like this, reference. That's a better name to put for it. So essentially, it's got to be reference of A. Why? Because it receives the reference of A and returning it. Therefore, the function itself becomes reference of A. Does that make more sense, hopefully? Why we are doing this, it's not just because I'm nuts. Later on, you're going to see it's going to come really handy in future. That's why I'm calling it crazy reference now, for you just, play with it and say, what the heck? Question mark in your brain. When the time comes, I'm going to say, remember crazy reference? Now it's going to do this magic for us. Okay? So please remember this. So again, let me just run it one more time. So that's going to be 25. Beautiful. Definitely that's going to be in your midterm. Okay? This, you see, it's going to be a midterm question. So 11, crazy. We're good? Are we okay? Whoops. Down to this point. So what else I have? I'm just looking at to see what I need to. Oh, this is a good one. So in here we have array of pointers. I'm not going to teach that before I teach you what pointers are. And I think we have enough time now for me to go through the pointer lecture. I don't think it's going to take more than 10 minutes. And it's 1:07 and 1:20 the class ends. So I'm going to take you through the pointers thingy, okay? So 3 minutes break so I can prepare my stage, and then we're going to do the pointer thingy, okay? And I'm pausing the recording. One of your responsibilities as a student is that okay. So really? Oh, exit blank screen. Yes. Okay, so so how does this pointer thingy that I want to go through work? I am going to, let's assume that we want to design something ourselves to be able to, we want to design the pointer ourselves. Let's say there is no pointer in C language, okay? So we take it that way, usually because you know already what pointers are. It kind of ruined the thing, surprise, but so let's assume we don't know what pointers are, okay? Let's put it that way. So we know that your memory is essentially an array of characters that starts from the index 0 and goes up to how much money you have in your pocket, depending on how big your RAM is, right? That's essentially what it is, okay? When you create a variable, what happens? When you create a variable integer var, a piece of memory is kind of reserved for you, and it tags a name for it, so it belongs to you. We say integer var, you're going to have 4 integers over there. Attention to the screen, please. Okay? So, and if I create a double value, then it's going to hold someplace else that is actually free, and it's going to put 8 integers over there. Now, if I told you what is address of var, what is the address of var here? 108, correct? And the address of dvar is 132, correct? Yes.
Why only 1? Because there's like 4 addresses for each cell.
No, it's when it starts counts, right? From here you go 4 integers further. From here, sorry, 4 bytes further. From here you go, if you go over here, it's not a double anymore. It's halfway through the double. So it's the address of the beginning that dictates what it is. We good? Okay. So when you put a value inside a variable, it essentially overwrites the whole thing for you. And the same thing over here for the other one, right? So if you say double, it puts the entire variable. We good? Right? Now, let's say I'm not interested in the variable's memory. I'm interested where the variable is. For that, I need a type. Like you have an integer, you put an integer value in it. You call character, you put ASCII code of a character in here. You say double, you put a value in here. I want a type of a variable that is capable to hold the address of other variables. Let's call it a pointer. Okay? So I can say pointer PTR. It's exactly a variable because pointers are integers essentially, right? They're addresses. They're index of the characters in memory. Therefore, when you say pointer PTR, you can actually put some value in it, 102. But when you put the value 102, it is pointing to somewhere that nothing is there. You need to extract the value, the address of other things. Otherwise, what is a pointer for? It's like you have an envelope with an address on it and you put some garbage over there. Your letter is going nowhere. You need to put a valid address in there. And valid address is only where other variables sit, correct? So because of that fact, it's better to actually put a proper value like 108 so it actually points to the integer over there. Are we good? But you all know that we don't know where variables are. Because of that, I need to invent something else. We call it address of. So I'm going to say PTR is address of var, and therefore it's going to extract where the thing is. When I say address of, I'm asking the compiler, where is this? That's what it's going to give me, okay? And then I'm going to say target of PTR. When I say target of PTR is that, I'm telling to the compiler, hey, don't put anything in PTR. See what PTR is pointing to and put the value over there. Therefore, 234 goes to the target of the thing. Are we good with this? Yep. They're all English. I'm not writing any code in here. And then, sorry, it was for IPC, so we have printf. So when you say printf var, it actually prints 2345. When you say target of PTR, it's again 2345. And if you print the PTR itself, it actually shows the address of where the thing is sitting. Are we good with this? Problem with this?
Yes.
What's the problem?
No problem, but I have a question. What percent you the first time I see that?
Oh, it means unsigned. Percent U is unsigned. You didn't tell you? They didn't see it's IPC 144?
No.
So percent U means print unsigned. When you have an unsigned integer, you have to print it as unsigned, right? That's the problem with C language. You have to tell it. In C++, you just print it. It knows it's an unsigned. It prints an unsigned. It's polymorph. In C, it's not. You have to actually mention. Okay? So, what if I want to point to the double one? So I'm going to say now PTR is address of dvar. So it's pointing to the double, right? And then if I want to put some value in it, can it put it over there? Think about it for a second. 2 seconds ago, I was saying PTR is pointing to the integer. So it was overriding 4 bytes. Now PTR is pointing to a double. How does it know if it's 4 or 8? It doesn't know. So if I do something like this, compiler cannot decide from the pointer what type of an address it's dealing with. The pointer doesn't carry that. Pointer just says address. It doesn't say what is at the target of that address. Because of that fact, we cannot do this. This is impossible. Our design is flawed. To be able to do this, I have to tell to compiler that I have an integer pointer PTR, which means the target of PTR is always an integer and nothing but an integer. And therefore, all the things that I'm going to do will work for it. And if I want a double pointer, then I'm going to say double pointer dptr. Therefore, the compiler knows dptr is only going to point to a double and nothing but a double. Therefore, when I actually put a value in it, it knows how many characters at the target should be overwritten and all the good things that are supposed to happen with it. We good with this? Are we okay? So essentially what I was saying was, I will be able to say integer a is 10, and I would be able to say integer, I think it's pointer, I said, right? Integer pointer p is equal to address of a, correct? And I can say over here, C out, target of p, and what it's going to print will be 10. Are we okay with this? And when I compile and run this, this is what I'm going to get. Are we okay with this? That's essentially what pointers are. And how all the things that you get from pointers, that what pointers are, don't give pointers extra credit. You're just variables. Their job is to hold the address of the thing. The problem that we have is that we give it extra credit. When you are putting an asterisk beside it, you say asterisk p. You shouldn't say that. When you put an asterisk after int, you say integer asterisk a. You shouldn't do that. So what really these things mean, essentially? Pointer is presented by an asterisk, which means if you actually replace the pointer over there, that's what the syntax is. Integer pointer. So that asterisk that comes after the type, it literally means pointer. When you are saying address of, it's ampersand. That comes before a variable. So when you replace that ampersand target of, that address of with an ampersand down here, it literally means address of. And sadly, target of is again with asterisk, but this time instead of after a type, it comes before a pointer. So now if I actually write this, it becomes target of dptr and target of yada, yada, yada. Okay? And now take a look at my code. So how come my code worked? It was because of this. Include pointer.h. You see that? And take a look. I just said, wherever you see target of, replace it. Remember define from IPC? I say, whenever you see target of, put an asterisk. Whenever you see address of, put an ampersand. Whenever you see pointer, put an asterisk. That's essentially what it is. There is nothing extraordinary about it. Okay? So remember, pointers are simple, single variables. Don't give them extra credit. When you create an argument of type pointer, what do you have to pass to it? An address. When you are creating a double argument, what do you have to pass to it? A double. It's as simple as that. It's just a variable. Its job is to point to other variables. Nothing extraordinary. And because of that, target of is that. And so if asterisk comes after type, it means type pointer. Integer pointer, double pointer, employee pointer. They're all pointers. And the size of all these things are 4 or 8, depending on what your platform is. So a PTR is 4 bytes. DPTR is 4 bytes. EPTR is 4 bytes. It doesn't matter what is the target. If you are sending an envelope to an address, it doesn't matter if it's a house, apartment, or government building. The address size is the same. It's the exact same thing over here. Okay? So essentially, when you see asterisk comes in front of a variable, it means target of. Don't say asterisk something. So A is target of P. Target of T is X. And A is equal to B multiplied by target of C. say it that way, you will never forget. And E is equal to target of M multiplied by C multiplied by C. Okay? Which essentially means that. And that was pointers, very quickly. Okay? So I'm going to put these things over there, go home and digest it and see how it works. Okay? At home, you come the next day, we're going to go through an array of pointers. Are we okay? Yes. All right. Come over here. I'm going to push this thing up so you have it. Let me just push it first. Give me 2 seconds. Commit. Come on. Oh. And what is the NBB? Just NBB. All gone. So you were talking about overloads. Okay, so
I think I was going to ask the same question. You said that we can
you
show
can
this three different
yeah.
lines.
So and it is 3 different ways. So this is one way,
All
this
right,
is
nothing
2
inside.
ways, and this is so let me put it here. 1 way, 2 way, 3 way. And remember, these 3 are completions of others.
you
So
mean
if you
that.
have a line, you add a length after, it becomes that. You can add fill after, it comes that. Because that's the case, you can shorthand it like that, not to write the whole thing, by just adding default arguments. So essentially, if you ignore both, you have no argument. It's the same way. If you ignore the last one, you have only one argument.
How are you going to write that on this one? So for example, if you write this one,
60.
Is this works for this one as well?
It only works for that one. So when you write 60, so it says, okay, length is 60, I have 60, but I don't have the other one. What do? I put dash instead.
So either you're going to call both nothing or the first one.
Yes.
That's it. All right.
But because that character thing is completely out of whack, I cannot do anything with it. I have to have a
can't call the
separate.
second,
Yeah, you cannot do. So but because of that, I write a separate overload. They good?
Yeah.
Okay.
Can I ask a really quick question?
Go ahead. My 3, 4, 5 is screwed, but okay, go ahead. Let me actually stop the recording, by the way. Did I stop the recording? No. So let me just stop.